In this video, we will learn how to make the two-point perspective view of an object. So the important things before we go ahead with making the two-point perspective. Number one, that there will be two vanishing points in this case. Unlike the earlier case where we were only having one vanishing point, in this case we will be having two vanishing points. So if you have an object like this, a building like this, so you can see the two-point perspective will have one vanishing point on this side and one vanishing point on this side, and these will be called as the left vanishing point and the right vanishing point. This is another picture, a real photograph of a building, and again we can see that this has got two vanishing points, one on the left, one on the right. The second point to be kept in mind while dealing with the two-point perspective is that in this case there will be only one edge on the object that will be touching the picture plane. If you remember, in the one-point perspective we had one full face of the object that was touching the picture plane. In this case, in two-point perspective, there will be only one edge that will be touching the picture plane. So that edge in this case, in these examples, is shown here. This edge here is the edge that is going to touch the picture plane. Also in this case, this is the edge that is going to touch the picture plane. Before we go any further, let us have a quick recap of what we did in the very first lecture on perspective projections. So these are the basic elements used in perspective projections. There's a ground plane, there is a picture plane, there is a horizontal plane, there is an observer standing at finite distance from the picture plane, there is a ground line which is intersection of the ground plane and the picture plane, there is a horizon which is intersection of horizontal plane and picture plane. As said earlier, in case of two-point perspective projections, we will be presenting the object in such a way that one of its edge will be touching this picture plane. So the object will be so placed that one of its edge will be touching this picture plane. So for example, in this case, this edge which is highlighted as yellow here shall be touching the picture plane here, and everything else other than this edge, all vertices, all edges will be on the other side of the picture plane, and this edge here that is touching the picture plane, only that edge will be available in its true length. All other vertices, all other edges, since they will be away from the picture plane, so they will be appear to be shortened. In addition to all this, there is also one difference in the two-point perspective as compared to one-point perspective. That difference is that in case of two-point perspective, the viewer's position has no lateral offset. What does it mean? It means that the observer will always be standing along this line here, so that this observer here is always in alignment with this edge. Like in case of one-point perspective questions, sometimes it was given that the observer is on the right side or is on the left side. In this case, that information will not be there because observer will always be standing in alignment with that edge which is touching the picture plane. So let us start with the problem. So in this case, the problem is that we have to draw the two-point perspective view of the object that is given here. Now in this case, you are given the isometric view of an object. In some cases, it may not be isometric view, it may be directly front view and the top view. In addition to these geometrical details, the data related to the location of the station point, the horizon line and the ground line is also given. Now, just for the sake of demonstration, I've just put some names here, the names of different vertices starting from A, B along this chain. And for the ease of understanding, let us also put some color here. This is the given object with the dimensions. Now please take care that in this case, this data about the horizon line and the ground line with respect to the picture plane is only given so that the students can make their drawing in a proper way and it doesn't go outside the bounds of the drawing sheet. Otherwise, this data can be indirectly given as the height of the eye level of the observed. Now let us see what are the different steps that are required. The first step is that we draw the picture plane line. Now the second step is that we have to draw the top view of the given object with certain preconditions. So the two preconditions to be followed in this case are: number one, the top view is to be so drawn that one corner of the top view should touch the picture plane line. And the second condition is that the top view should be so placed with respect to the picture plane so that one face, which should be the face with more geometrical details, that particular face should be making 30 degrees to the picture plane line in top view. Now let us understand the meaning of this. This is very critical step in the 2-point perspective projections. So if we look at the given object, this is the given object, and if we make the front view of this object looking in the direction of this arrow, then we can extract three views. One is the front view, the top view, and the right hand side view. Now we have to take a call. Since this is the top view, anyway this top view is going to be drawn in the second step, as mentioned here, that we have to draw the top view. So we have to choose out of these two, the front and the right hand side view, which out of the two gives more geometrical description. Now if we look at this yellow colored face here, this is basically showing the overall profile of the object, that is how this object will look like throughout its depth. And the other view here, that is this one, the side view, is actually set of two rectangles. These two rectangles are separated by this dark line here. So it means there is one rectangle for this face, there is another rectangle for this face. So we can say that the front view out here is actually giving us more geometrical information, more clear-cut geometrical information as compared to the right hand side view here. So we shall be considering for this step number 2 here, we shall be considering this yellow colored face to be the one which has more geometrical importance. Now second step, we have to see that this chosen face which has got more geometrical information, where is this yellow colored face appearing in the top view? So in the top view, this line here, basically this line represents this yellow colored face in the top view. So this line is very important, this line in the top view. Now this statement says that we have to make this particular line, which is nothing but the yellow colored face, this line should be making 30 degrees with the picture plane line. So that is what it means in 3D. So this is how you should interpret it. So this is the ground plane, this is the picture plane, the object is placed on the other side of the picture plane, the observer is going to stand somewhere here at certain distance. This red colored edge is the edge that is going to touch the picture plane and it is going to appear in its true length. And the object is now so placed that this yellow colored face, the one which is more descriptive, that face is going to make an angle of 30 degrees with the picture plane, and the other face will be making 60 degrees because this included angle here is 90 degree. So if this face makes 30 degree with the picture plane, this is another 90 degree. So this edge here will be making obviously 60 degrees. Now this entire concept, when viewed from top, if you are sitting here and you are looking at everything from here, so this will look like this. So this line here is actually the picture plane. This is the top view of the object. This red color line, you can see this line is the face, which is yellow colored face, which has got more geometrical description. So this face is making 30 degrees here, and since this angle is 90 degree, this face will be automatically making 60 degrees to the picture plane line. Now this step is very important while making 2-point perspective. The next step is that we have to locate the station point. Now when it comes to locating the station point, the data may be given in two different formats in the question. So the first way in which the location of the station point may be given is that you might be given directly in the statement that station point is so much distance away from picture plane. Say that distance is given to be d. So in such cases, this distance d will be explicitly mentioned in the statement. So this distance d is given. Now if that is the case, then so this line here represents the picture plane. This is the top view as explained in the previous slide, and to locate the station point right from this corner, just draw a vertical line and you move along a distance d which is given, and this is the station point. Now in the second case, the distance of the station point from the picture plane may not be given in the statement directly. So it means that this distance d of the observer from the picture plane is not given directly in the statement. Now in such cases, what we will do, when we make the top view as explained in the previous slide, we measure this horizontal width of the top view. That is, we just find this diagonal width of the top view. Now to locate the station point, we move from this point, we draw a vertical line from this corner of the top view, and along this line we move a distance which is equal to 2 times this horizontal width, that is 2x. So this point here is the station point. The next step is to identify the vanishing points, and we all already know that the vanishing points always lie on the horizon line, and in this case you will be finding the two vanishing points, the left vanishing point and the right vanishing point. Now the first step to locate the vanishing point is that we draw the horizon line and the ground line as per the given data. Like in this case, the horizon line is given to be 50 mm from the picture plane, and the ground line is given to be 140 millimeters from the picture plane. So we just draw these two lines. Then we draw two lines passing through the station point, and these two lines are drawn parallel to the lower edges of the top view. This line here is parallel to this line of the top view, and this line here is drawn parallel to this edge of the top view. So we just draw these two lines through the station point, and these two lines are parallel to the lower edges of the top view. These lines meet the picture plane line here at this location. This is say L1, this point, and this point is say L2. Then from these two locations, that is L1 and L2, we just drop two vertical lines onto the horizon line. So these 2 points here, they are the left vanishing point and the right vanishing point, since the vanishing points always lie on the horizon line. The next step is to draw the perspective view of the boundary box of the given object. Now, what does it mean? So if the given object is like this, and this view here shows the boundary box of the given object. That means this object can be completely fitted within this framework here, that is called as the boundary box in this case. Now what if we have to draw the perspective of this boundary box? So the perspective of this boundary box should look like this. Now just for the sake of identification, I am naming this vertex as A double dash, this as H double dash, this as 7 double dash, and this as 1 double dash. So the perspective view of the boundary box looks like this. Now let us switch over to the AutoCAD to see how to make the perspective view of this bounding box in AutoCAD. So this is the picture plane, this is the top view of the object as explained earlier, and the horizontal width of the top view in this case is 138, and accordingly the station point is 276 millimeters along this vertical line from the picture plane. So that is the station point. The horizon line and the ground plane line have been plotted according to the given data, that is 50 and 140 millimeters, so that makes 90 mm. Then subsequently these two lines, that is lines passing through the station point, have been drawn, and subsequently we have got these two vanishing points, that is left vanishing point and right vanishing point on the horizon line. So this is all as described in the previous slides. Now we are going to make the perspective of the bounding box. For the sake of understanding, I have just drawn the isometric view of the given object in a box here. So the overall height of this box is A double dash. So that is total 60 millimeters. Since we know that one edge of the object is going to touch the picture plane, and that edge is always going to be in its true length, so in this case we are saying that this corner here, that is A double dash, is touching the picture plane. So it means this edge here should be appearing here in its true length. So what we do, we just start with the first line, that is starting from A up to 8 double dash. So this line is 60 millimeters. So that is the height of the box. That is the maximum height of the box. This is 60 millimeters. Then next we connect the two vertices of this line to the two vanishing points on both the sides. So starting from here, you draw this line to the vanishing point, then back to the top end of the same line. Similarly, you draw one line on this side on till the right vanishing point and back. Now we can just name these 2 points here just for the sake of clarity, that this edge here is A double dash. Now since only one edge of the box, that is A double dash, is touching the picture plane, so only this edge should appear in its true length. All other edges like H double dash, 1 double dash, and 7 double dash, all these edges in the top view, they do not lie on the picture plane line. So it means anything that does not lie on the picture plane has to appear as shortened one. So to draw these shortened edges, we just need to resort to the same procedure that we followed in case of 1 point perspective. That was, anything that does not lie on the picture plane, for that vertex we have to find a piercing point. So what we do, we join, let us say, vertex H with a station point like this. I'm just dulling the color. So we join this vertex H with the station point, and somewhere here on the picture plane, this point of intersection is the piercing point for vertex H. Then from this piercing point we draw a vertical line until this edge here. Now what is expected, that edge, vertex H or H double prime, should lie on this edge or on this edge. H double dash will lie on this edge, H will lie on this edge. Now since we have got the piercing point for H and H double dash at this location, so we draw a vertical line from the piercing point onto these two edges. Then we can trim this line. So, and just for the sake of clarity, I am also trimming this line because this line was used to locate this piercing point here. Now this vertical line that we have just dropped from this piercing point, this is actually H and H double dash. So this line here is actually representing H and H double dash. Same way we can find the piercing point for 1, that is connect this 1 with the station point, and we get the piercing point for 1 somewhere here, and then from this piercing point of 1 we just drop a vertical line, right? And I'm just deleting this line, otherwise you can keep this line. I'm just deleting it just to declutter the view. So this was the piercing point for point 1. Then from here we draw a vertical line. So this point here is 1 and 1 double dash. These 2 points here are 1 and 1 double dash, right? I can also trim this part of the line. Same process can also be adopted for the last point, that is point number 7. You connect 7 with the station point, you will get the piercing point for 7 on the picture plane line. Then from that piercing point draw a vertical line, and so on. But we can also get point number 7 here in a shorter way. That shorter way is that since we know that 7 is going to lie on this edge that passes through H, and 7 also has to lie on this edge which passes through point 1. So 7 can be located by drawing this H7 and 1 7. Now H7 or H double dash should lie like this, H double dash connected with the right vanishing point. Similarly, we can draw a line connecting 1 double dash with the left vanishing point. Now I'm just going to zoom. You see where these two lines which we have just drawn, H double prime going to the right vanishing point, and this line starting from 1 double prime going towards the left vanishing point. So this point of intersection here is actually the required point, that is point number 7 double dash. So this point here is actually, let me just rename it, this is 7 double prime. So that is how we can get the perspective of the bounding box. So we can just trim the unwanted lines to get a clarity on the bounding box. So all these lines will go, and finally we are just left with sorry, this bounding box. Now I'm just going to make all these lines of a different color so that we can easily view. Okay, so this box here is the perspective of the bounding box. Now just for decongesting the space here, let us delete these names of the vertices. Okay, and now let us also have the detailed isometric with all the vertices named properly. Now we have just made the perspective of the bounding box. Now let us start making the perspective of the full object. Now in this case, where does AB lie? The edge AB. AB edge must lie on this line here. And since this is the edge representing its true length, so we should draw a line which is 30 mm, because true length of AB is 30 millimeters. So from this point we draw a vertical line which is 30 millimeters. So this line here is representing the edge AB. Now I have to get this edge BC here. So BC should go this way. So if I just put the names of the vertices also, so this is vertex A and B that we have just plotted. Since the space is very small, so I just have to manage the things here. Okay, so this is A and B. Now this edge BC should lie on this line, which should start from B and it should go to the left vanishing point. So I should draw one line which should start from B and it should go towards the left vanishing point. Now on this line itself should lie point C, and later also point F and point G. So point C, F and G should lie on this line which starts from B and it goes in this direction. Similarly, if I am to look, I have to draw point 2. So point 2 should lie on this line which starts from B and it ends at the right vanishing point. Right? So these are the edges on which point 2 will lie and point C will lie, point F and G will lie. Okay, now straight away we can make out that this edge here, since this A1 is common with the bounding box, so this point here is nothing but 1. So if I just name this point here, this is actually point 1, right? And this edge I can make it dark, so this edge is A1 and this is the final edge. Now this vertex 2 should lie on intersection of B2 and 1, 2. So in this case I have got this edge joining B with the right vanishing point, and I have got this edge also here which is passing through 1. So the intersection of the two here should be vertex 2. So we can just draw these dark lines from here like this. So this is vertex numbered 2. So that is vertex number 2. This is vertex number 2, right? So we have completed this face A, B, 2, 1 here, and just for the sake of clarity, we can also put some color here, the same color. I can just use the match property command, match this property with this property, so that is the face AB21. Now I have to locate point, say point C. So point C in top view is actually represented by this point here. Actually this is C as well as D, because in top view D and C will be same location. So I just do the same process. Since point C as well as D, these 2 points do not lie on the picture plane, so I just need to connect this point, that is point C, or you can call it point D also, with the station point somewhere here, right? So I get the piercing point for C as well as D. Then from this piercing point we draw a vertical line, right? Just for the sake of clarity, I'm trimming this line which I just used to find the piercing point. I'm just sacrificing this line, but otherwise you can keep these lines in a different layer, or you can choose a very light color. So this line is coming from the piercing point of C and D. Now this vertical line is actually giving me point D here, because D is expected to lie on this edge. Now this edge is actually this edge here in the isometric. So point D lies on the same edge as this one in the perspective. So this point here is actually point D. So I can just name it as D, right? So this point here is point D, right? And just below point D should lie point C. Just below point D should point lie C, and it should always lie on this edge. So the edge coming from B, that is this one, and this vertical edge here, we are going to get point C here. So if I just copy this and place it here, so this is my point C, right? So this is point C, and I can just trim away this much line segment and make these line segments dark. So starting from here up to this location, so that is point, so that is B, sorry, this is C, this is C, so this is B, C, D. Now we have to get point E. This is point E here. So this point here is actually point E. So we adopt the same process. Since E does not lie on the picture plane, so we first get its piercing point. So how do we get the piercing point? To get the piercing point, we connect the point E here with the station point here, and we get the piercing point of E somewhere here. Then from that piercing point, I just draw a vertical line. Just for the sake of clarity, I am deleting these lines. This line is deleted. So this vertical edge is coming from the piercing point of E as well as F. So E should lie on this line, E should lie on this line, and F should lie on this line coming from B through C. So this point here is point F, and this point here is point E. So I can just copy paste this point here. So this is point E here, and this is point F here, right? And we can also make these lines dark because this is point D, this is point E. I can call the intersection, so that is point actually E, and this is point F, and logically this is point again I'm calling the intersection, so this is point G, and just below G I can find this point as H. So this chain is complete. This is G, so this is G, and this one is H. Right, now we are left with these points, that is IJ and KL. Now IJ and KL in top view, say this point here K is actually represented by this dotted line here. Right, now this point again does not lie on the picture plane, so I adopt the same process. Connect this point with the station point, you get the piercing point, bring it down, and you'll get point K and L here. But the important thing here is that the KL line, actually the true length of this KL, if you just find out from the given data also, this is actually I think this is 15 millimeters. So KL is actually 15 millimeter, but KL does not lie on this edge, that is AB, which is appearing here in true length. So KL is away from the picture plane, though its true length is 15. So that 15 true length will appear to be foreshortened. But how do we get that reduction factor for the length of KL? So what we do is we just draw KL, the true length of KL somewhere here. So I just make a line here which is 15 millimeters high, right? 15 millimeters high. So if I just give it a different color, this one, I'm just calling that this line is my KL line. And this is the case if KL would have represented in its true length, it would have been like this much, 15 millimeters. But since point K and L do not lie on the picture plane, so it has to be foreshortened here. Now to get that reduction factor, what I'm going to do is I'm just going to connect this end, which is the top end of 15 millimeter, with the vanishing point, right? So this line here is actually coming as and if it is true here at this location, that is 15 millimeters. Now on this line should lie point K and L. So how do I get K and L? I just connect the point K and L in top view with the station point here. So I get the piercing point of K and L here. I just drop a vertical line, right? I just drop a vertical line here, and then just for the sake of clarity, I'm deleting this line since I just want to have a clear picture. So this point here is this point here, right? If I just make it dark, let me just make it dark, from this location, sorry, from this location to this location and back to A here. So this is point K and L. This is K and L, right? So this is K and L. These 2 points here are K and L. That's K and this one is L here. So this is L here. And now lastly I have to locate point J and I. So the process is same. J and I is somewhere here in the top view. I get the piercing point for J and I. So somewhere here is the piercing point for J and I. Draw a vertical line, and wherever this vertical line, I'm just trimming this line. So wherever this vertical line from the piercing point of J and I intersect with this edge, this point here is J and this point here is I. So I can just make these lines dark, that is starting from H, this is I, this is J, and back to right here, that is K. So these are the different points. Now I'm just going to zoom it so that you can see all the points clearly. So that is how we get all these points here. That is A, B, C, D, E, F, G, H. So this point is actually here. This point is here. This is F, and I can just rename this. This is I, and this is J. I hope the things are clear. So we have completed the edge chain starting from A, B, C, D, E, F, G, H, I, J, K, L, and on this side we have located point 2 and 1. Now since the object is like this, so all these edges like A1, B2, C3, D4 and E5, G7, and even this edge going through I, all these edges should be going towards the right hand vanishing point. So in this case what we just need to do is we just need to draw these lines connecting all these vertices. That is, we have already connected B and A, so we will connect C with the vanishing point. We will also connect D with the vanishing point. Then we will connect E with the vanishing point, and then we will connect G with the vanishing point. Likewise, we will lastly join I with the vanishing point. Right? Now, lastly, we can connect this point to with the left vanishing point on this side. So that's left vanishing point. Now I'm going to zoom it so that we can see all the things very clearly. Okay. Now we can just make the required edges dark. To start with, I start from here. This edge is dark. This edge is also dark. Then starting from E right up to this edge, and then right up to this location and back to D here, so that is dark. Then from C I can darken this edge here, and if I connect it, these 2 points should lie in a vertical line. So finally I connect this point here with 2, and this point here is B, right? And we can also make the other layers invisible to get the final look at the perspective view of the given object. If you are interested, you can also remove these names of the vertices and put the proper shading to compare the perspective with the isometric. So I can just put the colors, like this one is a yellow face, this one is yellow face, okay, and this and this face are green as we saw it in top view, and lastly this face is like blue, so I can use the match property command, match this color with this color. So that is the required perspective of the given object. Now just to compare this perspective with isometric, so that's the perspective, and Okay, just let me just zoom it out. That's the given perspective. So that's the comparison of the two. So this is the perspective and this is the isometric. Now you can see in case of perspective, this edge, all edges in this direction, they are parallel. Whereas in case of perspective, all these edges, they will intersect each other, and that point will be the right vanishing point. Similarly, edges along this direction in isometric, they are again parallel to each other. Whereas in case of perspective, these edges along this direction, all these edges, if extended, these all edges will meet at the left vanishing point. However, the vertical edges are parallel even in 2-point perspective. These all edges are vertical and thus they are parallel to each other, like in case of isometric also. In isometric, the vertical edges are parallel, and in perspective also the vertical edges are parallel if it is 2-point perspective. One last very important point. In case of isometric, we know that this edge, that is edge AB, was given to be 30. Now when we make the isometric of, when we make the perspective, this edge and only this edge, nothing else, only this edge is represented in its true length, that is 30. If I compare this edge in perspective with the corresponding edge in the isometric, then there will be some difference in the dimension. Like in case of isometric, you can see that this edge is also 30, whereas the corresponding edge in the perspective will be smaller than 30. It will be something like 26 or something, right? So only one edge in perspective, that is this edge, is represented in its true length, and this is the edge which is touching the picture plane. All other edges except this edge, all other edges in the perspective, they are away from the picture plane, so that is why they are shortened in their lengths. So that is the reasoning, and that is what adds some element of realism in perspective drawing, that something which is closer to us, this is the closest edge, this is bigger as compared to any other edge which is relatively at a larger distance from the observer. So I hope you have learnt the steps that are required for making the 2-point perspective. In case you have any doubt, you can contact me or your respective group teachers. Thank you for watching the video.